Okay. Assalamualaikum warahmatullahi wabarakatuh. So today I will present about the role of mixed ionic electronic effect in ionic to covalent glass network transition and its effects on non-linear optical properties. So I'm Muhammad Sidi Fadil bin Sutrisno. So I'm supervised by Dr. Rosdiana binti Sam and Nur Syahidah binti Sabri. Okay, so for the introduction, so the mixed ionic electronic effect is the phenomenon that occurred in mixed ionic electronic glass. So mixed ionic electronic glass will be composed of two components. It is first from the monovalent cation from alkali metal, and second is from the transition metal oxide. So monovalent cation will contribute to the ionic conduction, and transition metal oxide will contribute to the electronic conductivity. And with those two different kind of conductivity, then will lead to a conductivity minimum, such as if you see from the figure here, with increasing of vanadium, there is the transition metal oxide. So we expect an increase in term of conductivity, but the reality is we will have a drop at 0.8 in this lithium, molybdenum, and tellurium vanadium oxide glass. Okay. So we come to our problem statement. So in our earlier work, we had done also our characterization on this mixed ionic electronic glasses. It is composed of lithium, bismuth, and telluride, our glass. So we had done characterization on the dielectric constant, AC conductivity, and refractive index. So it is the optical properties. We observe also that we have the minimum, the drop. It is on 7 mole percent here, you can see, and then the drop here start at 7 mole percent, and this drop is also at 7 mole percent. So generally we will have a minimum at 7 mole percent that indicate the mixed ionic electronic effect occurred in our glass samples. But the problem is, even though we had the reports on the dielectric conductivity and optical properties, but we are lack of the observation of this mixed ionic electronic effect, whether it will affect the non-linear optical properties or not. So then we are here to do this research with several objectives. First, it is to study the mixed ionic electronic effect on the non-linear optical properties such as the non-linear refractive index and optical susceptibility. And then it is to elucidate the structural changes occurred in mixed ionic electron effect. It is to study, to observe the optical basicity, inter-ion interaction parameter, non-bridging oxygen unit fraction entry, and then the last will be oxygen packing density of the glass system. So we do some experimental. First is we prepared the glass powder, and then we use a melt quenching method. So we melt first and then we quench it, and then we do several characterization. It is first structural characterization, we use FTIR, optical absorption, we use UVVs, and last conductivity measurement, we use impedance analysis. So we got this result. So if you see from here, the non-linear optical properties result, it is a non-linear refractive index. We observe also the minimum. Okay, at first it is increased, and then we have a drop here, the minimum, and then it increase again. Also in dielectric susceptibility, before 7 mole percent it is increased, but at 7 mole percent it also decrease, drop, we have a drop, and then it increase again. So we are thinking on how this can occur. It is due to the M blocking effect in MIE region. So at first we have high polarizability due to the high formation of NBO that can lead to the increase in anharmonic polarization. But in 7 mole percent we have the blocking effect, and then this will induce the higher formation of BO, and then it will lead to the less contribution of electron density to the anharmonic polarization. And then after 7 mole percent, the the polarization will be increased again due to the high polarizability of Bi3 plus cations and higher formation of NBO. So then we can have the increase in anharmonic polarization that will increase both the nonlinear refractive index and also the dielectric susceptibility. We observe also on the structure of the glass samples with increasing bismuth concentration here. We can see that uh, here is the optical basicity. Here is the trend for the interionic interaction parameter. For the optical basicity, we can observe here the increase in optical basicity before 7%, but it is due to it is indicated the increase in ionicity, ionic character of this glass sample due to the high formation of non-bridging oxygen that increase the electron donor character of the oxygen. But at 7%, we have blocking effect. We have the MI region. So this blocking effect will decrease the oxygen donor character and then will promote the covalent bonding. So you can observe there the low value of optical basicity indicate the more covalent nature of this class sample. We have done also the interionic interaction parameter that want to observe the interaction between cation and anion. It is indicate the covalent nature, the shared electron between the cation and anion. So we can observe here the decrease of A, the interionic interaction parameter before 7%. So it is due to the large amount of unshared electron density. Then it will increase the ionic bonding of this glass sample. But at 7%, we have the reducement, the blocking effect. So this blocking effect will reduce the unshared electron density between cation and anion pair, then favor the formation of covalent bonding. So you can see here the high value of interionic interaction parameter here with approximately constant. It is due to the formation of covalent bonding. So from this we can say that as the 7%, the MI region is somehow become a place for the transition from more ionic nature of the glass sample to the covalent nature of the glass sample. So we observe also using FTIR. So we can observe the entry here, the non-bridging oxygen unit. So we can observe the high entry here and the low oxygen packing density here. This is before 7%. It is due to it is indicated the loosely packed structure. So that indicate also the low formation of PO. But after 7%, we can have both of them are increasing. It indicate the highly compact glass. So due to the high formation of bridging oxygen, that will contribute to the covalent bonding. So it can say that after the mixed ion-electron effect, the promotion to the covalent bonding is started and increasing. So as we are somehow thinking about what is the blocking effect. So blocking effect we can observe by using this DC electron ionic conductivity. So this ionic conductivity we can have the increase in ionic conductivity before 7% and also increase in ionic diffusion, lithium ionic diffusion before 7%, but after 7% we can have a drop and also low, approximately constant low value of both DC conductivity and also ionic conductivity and also the ionic diffusion of lithium. So this is the increase before 7% is due to the formation of NBO that will lead to the easy migration of lithium ion and also lithium ionic diffusion throughout to the glass that contribute to the conductivity. But the drop of 7% is due to the blocking effect. Then it will cause like a barrier to the lithium ionic migration of ions, and then will lead to the low and approximately constant value of conductivity. So it is we can say this like a blocking effect phenomenon. So it is like blocking to the lithium ions migration. So it will cause the drop in ionic conductivity. So conclusion, we can the glass sample showed more ionic nature based on our observation of the cell parameter before 7%. And 7% is suggested to be the MI region and also the transition region from more ionic to more covalent nature of the glass samples. And then the last, after 7%, we can observe the more covalent nature based on our observation on these parameters. Okay, so thank you.